Welcome back to Topic 8 for Algebra 1, Write, Graph, and Solve Compound Inequalities. In Part 2, we're going to focus on solving complex compound inequalities and graphing them. Here's our first example. Y divided by 3 is less than 2, or y minus 4 is greater than or equal to 5. So we're going to treat these as separate inequalities at first, just for solving. We're dealing with one-step inequalities for both of the examples. On the left, we have y divided by 3 is less than 2. If we want to isolate our y, we see division, and the inverse of division is multiplication. So we're going to We're going to multiply both sides by 3. On the left-hand side, this is really 3 over 1, and it reduces, and we're just left with y. On the right-hand side, we have 2 times 3, which gives us 6. Now, because we multiplied by a positive number, our inequality remains true. On the right-hand side, we have y minus 4 is greater than or equal to 5. Since we see subtraction, we're going to add 4 to both sides, which is the inverse. Negative 4 plus 4 adds to 0, so we're just left with y is greater than or equal to positive 9, because again, we're adding or subtracting a number here. So our inequality remains true. Now I'm going to bring down my or statement. So y is less than 6, or y is greater than or equal to 9. If I'm dealing with graphing, I have 6 on my number line, 7, 8, 9. Now, since y is less than 6, this is an open circle. And all the values that are less than 6 go to the left. Since y is greater than or equal to 9, this is a closed circle. We see that equal bar underneath it, so we know that our circle must be closed, stating that 9 is a possible solution. Since y is greater than or equal to 9, we're going to shade to the right because it's all the values that are 9 or bigger. Now, because we're dealing with our or inequality here, our number for y only has to satisfy one of the inequalities. It could satisfy both, but it only needs to satisfy just one, which is why we can include both of our graphs on our final number line. Looking at number 2, we have 1 is less than 2x plus 3, and negative 2x plus 3 is less than 19. So here, again, we're dealing with two different inequalities. They look very similar, but just a little bit different. So what we have here on the left-hand side, we have 1 is less than 2x plus 3. We want to isolate that x. So if we think back to topic 3, when we're solving two-step equations, we want to get rid of that third wheeler, that straggler first, which is our positive 3. So we're going to subtract 3 from both sides. On the right-hand side, 3 minus 3 adds to 0. So we're just left with 2x. And 1 minus 3 is negative 2. Now again, we want to isolate our x, so we're going to divide by our positive 2 because that is what's holding on to dear life to that x. So we're going to divide both sides by that positive 2. 2 divided by 2 is 1, so we're just going to be left with x. Now we have negative 2 divided by 2 on the left-hand side, which gives us negative 1. Because we're dividing by a positive number here, we do not need to change our inequality sign. Since negative 1 is less than x, another way that we can actually rewrite this is x is greater than negative 1. Remember, thinking back to the alligator or crocodile, whatever floats your boat. Since our inequality is eating the x, it is the bigger value. So we can flip the position of our variable and our number here, but we also have to flip our inequality. Okay, why don't we graph this while we're at it? we have our number line. We have -1. This is an open circle. Since x is greater than -1, we're going to shade to the right. Another way that we could get from this step to this step is if we either multiply or divide both sides by a -1, just like we did in topic 7. Since we are multiplying or dividing, then we would have to flip our inequality, which is why this still remains true. So even though I didn't show the work, that's also what I did. So if you want to think back to the alligator eating the larger number or multiplying, dividing by a -1, that's how our inequality flips. Okay, on the other side, we have -2x plus 3 is less than 19. So we're going to isolate x again, first by subtracting 3 from both sides. We have -2x is less than 19 minus 3 gives us 16. Then we want to isolate x, so we're going to divide. Since we see multiplication, we're going to do division. Both sides by -2. Now here we are dividing by a negative number. So instead of x is less than -8, it changes to x is greater than -8. So we have to flip. If we want to graph this on a number line, we have our -8. This is going to be an open circle. Since x is greater than -8, we're going to shade all the values that are bigger than -8. However, if we look back to our original inequality, this is an and inequality. So our numbers for values for our variable have to satisfy both of these inequalities. So what are numbers that are both greater than -1 and greater than -8? So let's try, well, a number that's both greater than -1 and greater than -8, we have 0, that's bigger than both of them. 5, 10, 15, 20, -1/2 is also bigger than both -1 and -8. So if we want to graph this inequality, I'm going to have my -8 and my -1, but all the values that actually satisfy both of these inequalities, bigger than -8 and bigger than -1, are actually just all the values that are bigger than -1. Any of these values in between do not matter because it only satisfies one of the inequalities, and we want to satisfy both. Moving on to our next example. 1 is less than -2m plus 3, and -2m plus 3 is less than 19. So we first recognize that this is an and we also notice that this is the same value right here. So we can actually write this in a compact form because we're dealing with our and compound inequality. So this is the same thing as 1 is less than -2m plus 3, which is less than 19. We just sandwiched it in between. So now when we solve for m, it's going to look a little bit more condensed. Since 1 is less than -2m plus 3 is less than 19, we're going to solve this just like we would on regular two-step inequality. However, what we do to one side, we have to do to all of the sides here because we have two inequalities. So first what I want to do, I'm going to isolate that m ultimately. So I'm going to subtract 3. But I need to subtract 3 from every single side. So 3 minus 3 adds to 0. 1 minus 3 is -2. And 19 minus 3 is 16. Now, since I just subtracted a number here, my inequality remains true. I don't need to change anything. However, the next step, I have -2m in the center. I should say -2 is less than -2m, which is less than 16. I'm going to divide every side by that -2. Now here, notice how I'm dividing by a negative number. So when I simplify, -2 divided by -2 is 1. In the middle, I'm going to have my m. And 16 divided by -2 is -8. But what I do need to do is flip my inequalities. Because I divided by that -2 here. So another way that we could rewrite this, since this is 1 is greater than m is greater than -8, this is the same thing as -8 is less than m, which is less than 1. So if we were to graph this, we have my -8, we have my +1, open circles for both. Since m is sandwiched in between and it is an and inequality, we're going to shade in between. Numbers that are in between -8 and +1. Moving on to our last example, 3n minus 2 is less than or equal to 11, or 2n plus 8 is greater than 16. So here we're dealing with an or. On the first inequality, we have 3n minus 2 is less than or equal to -11. I'm going to add 2 to both sides. So I'm left with 3n is less than or equal to -11 plus 2 is -9. Then I have 3n is less than or equal to -9. Since this is multiplication, I'm going to divide both sides by a positive number. So my inequality will not change. -9 divided by 3 is -3. So n is less than or equal to -3. On the right-hand side, we have 2n plus 8 is greater than 16. We're going to subtract 8 from both sides. -8 plus 8 adds to 0. So we have 2n is greater than 16 minus 8 is 8. 2n is greater than 8. We'll divide both sides by 2. 2 divided by 2 is just 1n. So we have n is greater than 8 divided by 2 is 4. Remember, this is an or inequality. Now I'm going to graph. So I have my -3 and my +4. N is less than or equal to -3, so we have a solid dot here. And since n is less than or equal to -3, we're going to shade all the values that are smaller than -3. Since n is greater than 4, this is an open circle, and we're going to shade to the right all the values that are bigger than 4. And that is it. That was part 2 of topic 8 for Algebra 1. Write, graph, and solve compound inequalities. Thanks for watching.